One small step for man, one giant leap for mankind.
More than 6,000 satellites currently orbit Earth. Around half of these are no longer working, while many of the active satellites are essential for our modern world, be it telecommunications, weather updates, the internet and GPS. It's the unpredictable damage that space debris could do to orbiting spacecraft that's now a major cause for concern. There are over 129 million objects estimated to be in orbit that are larger than a millimetre.
The detonation would destroy outright any satellites caught within the radius of the explosion. From the point of detonation, an electromagnetic pulse, or EMP, would disrupt electrical systems on the ground and in orbit.
So for this latest edition of In Defence, I'm delighted to welcome Julie Holt-Jones to the studio here. Very warm welcome to you this morning. Space is the topic of the day at the moment. Not Star Wars, not Moonraker, not whatever, but you have 30 years of experience, hands-on experience in the space domain, and also uniquely directed and led sort of successful missions by the European Space Agency, by NASA as well, and also driven multi-national private sector space ventures as well. So you are uniquely well placed to provide us some insight into this domain, particularly through the defence lens, but I know we're going to end up straying well outside there. So Julie, a very, very warm welcome. Thank you so much for coming to see us today.
Thank you, a pleasure.
So I guess my starting question will be, why is space important from a defence perspective?
Where do we start? Collectively, and I'm going to broaden out straight away to the civil and defence domains because it's so intertwined. We are dependent on space. Nearly everything that we do has some dependency on space. And I think that let's just review that. Space, it's space services. It's what we get from the capabilities that are in space. So if we flip that and think about what would happen if we didn't have access to those space services, maybe that can demonstrate the point quite well. So if we didn't have access to telecommunications, position navigation and timing, Earth observation, or in defence speak, ISR, intelligence, surveillance, reconnaissance, what would happen? Well, we'd start to see that we wouldn't be able to access money. We wouldn't be able to get money from the ATMs. Our dialysis machines wouldn't work. Our timing signals on traffic lights wouldn't work. Our supply chains would start to break down. Transport would start not to be able to work. We would have no weather forecasting, so things could go wrong there. We'd have no advance warning of any disaster management, so forth. And then from a defence particularly point of view, when you start examining things like even just the timing signal of position navigation and timing, start thinking about how that's used within a defence context, from combat aircraft, from our encryption, from nearly every aspect that we can think of in defence, we use space. And in fact, if you, just from the timing signal, if you look at that one aspect alone, you're going back to warfare circa 1960s, and it's that serious. So I think it's a little hackneyed kind of expression, but from a point of prosperity and security, it's fundamental.
We've been in space for decades now, but it feels like in a connected world, that all the examples you use, society would be brought to a halt if we didn't have access to space.
Exactly.
And as a military guy, any asymmetric advantage you can have on the battlefield is key. So it feels like we've got to provide some security for space. So I'm interested in this dichotomy where there are rules, aren't there, about weaponization of space and the like. And yet, given that society is so dependent on it, military capabilities, precision-guided weapons, secure comms, we can't just ignore it, but we can't put weapons in space. How do we ensure some security? What's the strategy for ensuring access, free access to space, and how do we make sure that countries that don't align with our views respect those rules?
It's an incredibly difficult situation, really, because in space, unlike on Earth, there are no boundaries. And whatever you do in space will affect everybody in some way or the other. You can't clear an area to have for a battlefield. You can't secure out, take out the civilian, anything. Everything has a direct effect. The big one is solar activity. So solar storms, the last really big solar storm we had, which was called a Carrington effect, if that happened again, and it will do at some point in time, that could affect and knock out nearly all satellites for a certain period of time. The electromagnetic current produced by that solar event would even affect things like submarine cables.
How often do those things happen?
Well, the last event of that size, I'm talking about a massive event, the smaller events, and we do have a certain amount of hardening and protection in the systems, but the very large, massive one happened around in the 1800s. And therefore, people started getting a bit nervous about when the next one's going to happen. And of course, then we'd had none of the capability in space. So that's something from a natural point of view, and that's why we are very concerned and monitoring space weather. The one that sort of bridges, let's say, a hazard and a threat is space debris. There's a lot of historic debris in space, but of course it also has been deliberately produced by certain countries, Russia, China, actually India, with direct descent anti-satellite missiles, ASATs. And obviously that's a hugely dangerous thing to do. There's another event, process called a Kessler event, which is almost like a domino effect of debris, which can cause massive problems for everyone. In fact, in LEO, it's the worst problem and it's the most congested orbit.
Most people would be aware that lots of establishments track space debris, but there's a limit to the size that can be tracked, isn't there?
Over 10 centimetres is something that can be tracked fairly easily. There are some organisations that are now to go into the sub 10 centimetre range, but it's much, much harder. And when we look at the damage, I don't know if we want to look at
Yeah, because one of the things that I fascinated before we came in here was that, I'd assumed that if it's less than 10 centimetres, most of us will go, oh, it's quite small, it can't do much harm. You've got an example of how something like the size of a grain of sand, the damage it can do.
Yeah. So this is a simulation. It's about 6 millimetre plate, and this shows you what would go typically orbital velocity in LEO. But as I say, a grain of sand. It's produced about, what would you say, Sean, about a centimetre wide.
Well, you can get your finger through that hole, can't you?
So there we go. So about a centimetre wide entry, and you can see the scorch marks on the back.
And that's a fairly substantial aluminium plate, isn't it? It's not a wafer-thin plate.
No. In space, you'll be much, much thinner than that. It does vary. And for example, the International Space Station has a double skin. Again, not as thick as that. And then you think about how small the piece and what hole it's made. So it's a really significant issue. And, I was mentioning before we came in that, when I started out in spacecraft operations, very rarely had to move a spacecraft or something like that. Now it's an everyday occurrence, which obviously affects the lifetime of a spacecraft.
Well, because the lifetime of a spacecraft, if it's just sitting there doing nothing, the magic would be forever because it's recharging its batteries. But it needs fuel, doesn't it, to move its orbits?
So it's limited by, so even once we get into its orbital slot, we have a housekeeping box, about 72 kilometres dimensions. You still need to do very small, what we call housekeeping manoeuvres that uses small amounts of fuel to thrust to keep it in that box and the orientation that you need. But not normally large manoeuvres to move it out of the way of other things. And so obviously this is a really big factor and is affecting the lifetime of some of the
and so just give us a sense of the impact that would have. So if you launched a satellite, I don't know, 40, 50 years ago, when there was maybe a lot less debris about, you wouldn't have to move it around so much. What would be the life expectancy of a satellite?
Well, I think generally now, when you're designing a satellite, it's something you have to build into the fuel budget, which then puts in up cost because it increases weight, which then increases launch cost and so forth. So it's something that's got to be factored in all the time now, unfortunately. So that has a knock-on effect. If I think about manoeuvring a spacecraft, if anybody's used to sort of manoeuvring a boat with a bow thruster, for example, it's that very fine-tuning little pulse of just to move. And sometimes you can even use a solar sail, which is those particles from the sun. And so you can get to use what we call the solar wind as an advantage. So there's different ways that we can use to try and preserve fuel. So going back to your original question, and I'll just briefly mention about threats. So threats in space, so sort of a kinetic event like a missile, pretty obvious, you can see that. The problem comes with all the non-kinetic threats, the jamming, the spoofing, the laser dazzling. It's all what we would call grey zone activity, incredibly hard to attribute activity in space. And then when you look forward to future technologies and the dual use aspect, this is where it gets really interesting. That's why it's incredibly important to try and track technology in the direction they're going so we can be ahead of adversaries, see how they're going to use that technology in an adverse way. For example, optical communication using lasers. Lasers of that type can also ablate the surface of a satellite. Gradually, bit by bit by bit, that will make its orbit decay. But it's so gradual, it's really very, very hard to actually understand how that's happened and where it's come from. And some of the future technologies, and this ties in with space debris, very, very important. Part of the agenda for sustainability, clearing up debris, active debris removal. Obviously, I think for everybody, it's very clear that actively removing debris for good can also actively remove things that don't want to be removed as well.
Well, I remember the film Moonraker. Was it the James Bond, where the big Soviet craft was going around munching up the satellites? Yeah. But as you say, if you've got to clean up, because I thought a lot of the orbital satellites these days were much smaller, but you were saying actually there's some pretty big old satellites sort of dead that are the size of a double-decker bus.
Yeah, the old ASAT satellite is the size of a double-decker bus. Gradually over time things have got smaller and smaller and smaller, but there's historic debris up there that's massive, and so it ranges from very, very tiny stuff to big stuff. So attribution in space is really difficult.
But there must be rules about this. So in attribution, what you're hinting at is people are trying to, sabotage or whatever satellites. So there must be rules about the weaponization and militarization of space. What are they, and are they enforceable?
So you will hear the term space is the Wild West. It does feel a bit like that. The key piece of legislation that we've got, or law that we've got, is the Outer Space Treaty. But that was from 1967. Things were a little bit different then. And all the parties, let's say, that subscribe to that, will we ever get those parties around the table again? Highly unlikely in the current geopolitical situation that we find ourselves. Of course, we have the UN, we've got sustainable use of space, we've got sort of NATO's involvement, but how do you enforce that? How do you make nations behave responsibly? And you can't.
The West traditionally has had an advantage in space. The Soviet Union and America were constantly in the space race or whatever. But since then, Russia is what remains the Soviet Union. Its economy is apparently about the size of Italy's. America, meanwhile, there's lots of technology and the development of space. If you were a country like Russia, North Korea, Iran, you would want to deny your adversary, America, the West, one of its asymmetric advantages. And one of the things was, there was talk about launching a missile full of sand into low Earth orbit. If that's the damage that one grain of sand could do,
exactly,
you could wipe out. There was also a story in the news, I think it was earlier last year, of reports that Russia was putting a nuclear weapon into space.
Yeah.
I just wonder, it seems inevitable that if you've got a space race and the West are ahead in technology, that others would want to deny that from us.
And if you look in the wording of the Outer Space Treaty, these things are fundamentally banned, let's say. You can't do this. You can't proliferate weapons. You can't take control of sections of the moon. You can't do this. But it's worded in such a way that adversaries are constantly finding loopholes and areas where obviously nuclear weapons is a pretty big one. We have seen sort of Russian dole effect of satellites being launched from Russia and then spawning another one. And we don't know exactly what the content of that is, but we were observing these things are happening. I mean, historically there has been a nuclear weapon actually deployed by the US.
No, I remember reading about that because the unintended consequences of
exactly
were huge.
Exactly, and so a lesson should be learned that's not going to be knocked out. Obviously, a number of satellites, allied ones as well, and caused a charging of particles around the Earth for a number of years. So it's obviously not a good thing to do. But anyway, we know that it's a problem, and we know it causes. And again, it affects not just your own asset, your adversaries' assets, but your own assets as well. So it's a sort of, why would you do that? This is it's a disruptive.
With a smaller country that wanted to deny that advantage, and it doesn't. Rockets, it seems to me, are becoming cheaper and cheaper to get stuff into space, and therefore there seem to be pretty significant risks from a military perspective. So I guess what I segue onto is that, therefore, you've got to stay ahead. You've talked about not an arms race, but a technology race. You've got to stay ahead of your adversaries. How on earth does a country like ours develop a strategy in that space when you're talking about huge sums of money, which we don't have?
We are one of the founding members of the European Space Agency. We have a huge amount of strong space heritage in this country. We're world leaders in many areas. Small sat exporting, space technology, R&D, amazing heritage in this country. There are certain areas where we really hold our own, which is amazing for the size of the country. Some of the supporting technologies that are now maturing, as you mentioned, over 30 years in the industry, and for me it's really the most exciting time to be involved with space, because not only are assets maturing, but the supporting technologies are maturing, which are making things that we knew about and we understood things that we could do. But that supporting technology, like robotics, for example, like PV technology, AI and quantum together will make us be able to make huge advances in space. And quantum, for example, we own some of the patents for quantum technology in this country. We're actually right up there from a European point of view. And the government has already identified about 5 different areas where they want to focus and accelerate and support, which are extremely important to do so.
But it sounds like that's a sort of an intellectual benefit that we have in this country. And intellectual can often be bought. Is it just becoming heavily reliant on the US and playing a niche role in that? Is it, or do you think there's another area that we should be prouder and own, and that becomes something that commercially as well as militarily becomes our USP?
From a defence point of view, I think it's really important, because people get a little bit hooked up on the US situation. I think it's really important to remember that space, doesn't matter, even the US can't do it alone. They do need their allies. And international collaboration is absolutely fundamental. And obviously from a defence point of view, we have some great organisations. Obviously there's NATO, also CSPO, the Combined Space Operations, is really important. And true. I think also we mustn't forget the emerging nations. And in some ways that's even more important, because we need to they're a bit vulnerable, and we need to bring them, I think we should bring them under our wing. And it's interesting from a UK point of view, from sort of my role in my consultancy, we often get approached by countries, we work in different countries, who want the UK style of doing things, who don't want to engage with the US because of they don't want to be absorbed in something bigger. There's certain countries that identify with the UK approach of doing things rather than the US. That's a really important aspect, I think. And also, every country has something to offer in some way, geography being a key one of them. We've seen recently the whole issue about Greenland. And that's a very interesting. We know, obviously, the Arctic is very important for defence. Maybe some people don't realise so much that satellites that are in a polar orbit, so that means satellites that can actually monitor, so we look at our ISR satellites over the polar regions, we need to have ground stations in the Arctic in order to take that data down to Earth. When we think about the space economy, I mean, roughly, but this is the World Economic Forum's estimate, which is 1.8 trillion by 2035. So we're talking about the growth of the world economy around about 9% a year. 11% is in the downstream. What I mean about is the data usage. So it's growing incredibly quickly. And 60% of that growth is from newcomers. It's incredibly staggering. And even if you say,
because the price of entry is just dropping all the time.
Yeah, and launch costs are coming down.
Yeah.
Launch costs are coming, which means, and once upon a time, and even when I started out in the industry, all the programs really were defined and governed by governmental agencies. And of course, launch costs coming down has meant commercial players can come in. It's made it more congested. It's more competitive. I mean, it's made it more dynamic. I mean, goodness me, it's so exciting to see all the new things that are coming online. But also from a security and defence point of view, it's caused headaches, really, because...
Well, the couple of questions that crop up from that. So, as a kid, I remember growing up watching the Apollo, everything like that. And I know we had some disasters along the way, but it didn't feel very often that we had a disaster. There seemed to be more successes than failures. If I look at the commercialization today and the rockets going off, Elon Musk and all these... there seem to be more failures than there are successes. Is that because it's now commercially, so the appetite for risk has gone up, people are driving down costs, and that inevitably leads to a more risky environment? Or is it just, this is the pioneering early days of a brand new set of technology that's being road tested?
Yeah. I think it's interesting you say that you felt that, we didn't have so many failures. I mean, the reality is with space, if you're going to push forward, you say a pioneering, failure is part of that process. And I think it has to be applauded, actually, and recognise that launching and getting into space isn't a taxi to space. And I think that mentality, something goes wrong, you don't do it again, is very dangerous. So when you're pushing the boundaries, as they are these days, then you're going to get failures because you learn from that and you learn a tremendous amount, and then you can push forward again and push forward again. So there's nothing wrong with seeing, these things that are going wrong.
But that must be a really good advantage, what you just, because they always talk about, when we do leadership talks, stuff like that, I always reckon I learn far more from my failures than I ever do from successes.
Exactly.
But the space program as a government program probably felt duty bound to be as safe as possible.
Yes.
Whereas in the commercial sector, they're far more comfortable with this fail, but fail quickly type mentality. That seems to be something so a couple of questions that flow from around that, one of which you mentioned the International Space Station. It does seem a bit odd to people outside the space program that we still collaborate closely with Russia in space when we've just described a domain which we're incredibly vulnerable in, and a country with the economy the size of Italy, and they've now invaded another country, that we're still collaborating with them in this Wild West, as you described it, of space. Do you think that will continue?
Space science has always been a collaborative, and it was always hoped that that space would be something different. That the geopolitics would be left on the Earth. We know that's not happening. So, from a space science point of view, the ISS was a collaborative thing to advance space science, and there's been some great advances there. However, the ISS is coming to the end of its lifetime. And what's coming next are commercial space stations. And so we're going to see the nature of that's going to change very dramatically. And I don't think we'll ever see something that we see in the ISS again.
And when do you think we'll see the first of the commercial space stations up and running?
We're looking in the 2030s,
Okay.
which are the timeline. But, in anything in space, you have to sort of take it with a pinch of salt because, it depends on so many different factors. But the ISS is literally coming, it's already gone over its lifetime. So we need to get those new ones online pretty soon. And actually manufacturing in space, experimenting in space, without going too technical, if you take away gravity from a manufacturing process, we can learn a lot more and about how processes work. So you can develop new alloys, for example. So there's two aspects. One, actually manufacturing space, but actually the other one is learning about processes and manufacturing on Earth. So there's already been progress in producing new alloys that can be used in fan blades of aero engines. Pharma, really important. That's already quite a big area, and very groundbreaking things for finding cures for cancer and so forth. Groundbreaking areas that we have an advantage when we conduct those experiments in space.
But given the vulnerability, we talked about the space station not only gets to the end of its life, but it's becoming increasingly congested up there.
Yeah.
When was it most recently that they had to vacate the main space station and get into one of the pods?
Exactly, when there was
So is it just that the next generation will be much further out because it might not be required to be as close into Earth? Is there some latitude to try and minimise the risk for people up there?
It's more likely to still be in LEO because remember we've got to get the astronauts up there if they have astronauts. And then that is another sort of hotly debated topic, which you'll find people are in very two big camps. So one, that what on earth are we doing with astronauts at all? Because we can do that with robotics. Obviously, they're inspirational, and we get a lot from the human experiments. And we'll see, from the point of view of bone health and so forth. But of course, there is this agenda about actually pushing forward and having humans on the moon or even Mars, as we've seen the agenda that's going forward in the US. And that's, I don't know if we even want to get into this area because this is another huge area which is a great favourite of mine, but the cislunar environment, which is important from a defence point of view, which is the area between the Earth and the moon. And then the whole kind of, you mentioned space race, there's almost like a lunar race going on at the moment. It'll be interesting to see what happens going forward from the US because we can see there's a little bit of a dance going on at the moment. But at the moment, there are a huge amount of missions that are scheduled to be going to the moon in the next decade. Around 800, I think, in the last count. And that's hugely driven by the US and the Artemis program. And it's been viewed at the moment to be like a staging post, and we're to learn a huge amount of things from activity on space, from for example, generating fuel from the water on the moon. It's an amazing, interesting thing.
I mean, when the whole moon, the populated moon or stuff like that, it all felt like a sort of bravado space race. But I've heard Musk and people like that start talking about, no, if you want to go further, you ideally want to be able to put stuff onto the moon. It's easier to launch stuff from a lower gravity of the moon to Mars than it is to do it from the UK. And therefore, if you could create some sort of establishment on the moon, and as you say, create water and whatever, it's not just a science project, is it? It's a way of then stepping stoning your way out to space.
And that's why most people strongly advocate that the stepping stone shouldn't be forgotten, that's exactly needed before you go into the even harsher environment of Mars. And it is obviously much further as well. So that's absolutely guided as important, but things are happening already. I mean, we have our communication satellite network. MESA is due to be launched in, I think the latest was 26. It might be pushed right a bit further right than that. But, this is happening. So, if anybody likes gazing up at the moon and seeing it in its pristine state, it may not look like that for very long. I mean, we are going to have a communications network around the moon. We are going to have scientific research bases, but scientific research bases with maybe a little bit of a question mark. We already know there's activity on the other side of the moon, which is hard to see from Earth.
That's why I wondered, it's the whole militarization again, isn't it?
Exactly. Which shouldn't be happening if you look at the Outer Space Treaty.
Yeah, because was it China that landed on
is on the other side. Yeah.
And you thought, why would they go to the dark side? And
exactly. And I specifically say it's always south side rather than the dark side. If you'll be pulled up by the purists, so you mustn't say that.
I'm a Pink Floyd fan, so you'll have to excuse the dark side of the moon thing. It rolls off my tongue.
Absolutely. I know exactly what you mean. And, in some respects it is. And, I mean, the temperature fluctuation on the moon is incredible, so. And there's some interesting factors about how you're going to, if we go back to sustainability, how do you sustainably dispose of your satellites around the moon, because there isn't an atmosphere to burn up into, and where can you fling them off to? So that's something actively being looked at, and actually something I'm personally involved with at the moment. But and then also there is a small amount of gravity on the moon. So if you jumped up, if you jump up in the air, no, you go up about 6 meters, something like that, and then come back down again. So there's a small amount of gravity, but obviously so much less. As you quite rightly said, it's much easier to launch from the moon.
Can I just, because I could talk to you for days about this stuff, and I appreciate it, but time is limited.
Yeah.
One of the things we heard, a whole flurry of announcements from the US under the new President Trump, and it feels like the whole Make America Great Again, and it's all feels like we're drawing into America again. In the space domain, it feels like we have to collaborate, otherwise we as a nation, we all have something to add, but we have to operate collaboratively. What impact do you think Trump's tenure might have on our space capability, our defense capability? Will it have any impact, or are there any positive signs that might crop up from this new 4-year term?
Well, actually, from a kind of space finance investment, the investment sector seems to be quite excited about it, because it looks like it's driving forward the agenda for space. So it would be interesting. The focuses might be different, but time will tell. But I don't think it's a negative for space. It looks like there's going to be a big focus. It's certainly not being shelved or being put on the back burner, and there's recognition of how important space is. So that's got to be applauded. And hopefully, as I say, we are dependent on space. We do need international collaboration. And from a space security point of view, I think it's really important that it isn't just our assets in space that are threatened. It's also the ground segment. We mustn't forget that. It's our ground stations, it's our data, the cyber effect. All these things have got to be looked at, and also our supply chain, because another reason for collaborating, the supply chain and the components that you need for space activity is absolutely huge, very complex, as you would expect. Obviously, you want to get those components from secure sources, so you need to work with your allies. So if you even look at, say, chips, you certainly don't want those coming from a source that is not secure. And this is an area where there's so many areas we could discuss. So from a dual use aspect, has huge advantage. I mean, I'm a big advocate of our resilience in PNT for the UK is really important. This is another area we could go into.
That's timing, isn't it?
The timing signal. Well, the position, navigation and timing, they're all important. The timing in some ways is particularly important. There's a national requirement for that, outside the defence, which is very important for all the reasons saying about, what would happen if we didn't have that timing signal. And some of that could be satisfied by, terrestrial clocks and so forth. But that's not the solution for defence, because especially for overseas activity. And there is a discussion about MOD time, having a resilience that's specific for MOD. However, for me, I personally think we should be looking at a national sovereign capability that satisfies both requirements. So we're looking at then the budget for DCIT and MOD and putting the two together. Seems absolutely, because we need it. I mean, the reliance on GPS is in the government's risk register as being a critical factor. It's critical that we are dependent on the GPS, which is getting a little bit old. And I think its vulnerabilities are pretty well documented. And the whole debacle about Galileo, which is, we had access to Galileo up to a certain extent, and then because of Brexit, we weren't then involved with the development. We were heavily involved with Galileo. We contributed a huge amount. But then when we stopped being involved with its development, we could no longer really subscribe to the secure signal, because we still weren't involved with the security aspects of development. So we've lost that capability. So, you've got Galileo is very successful and its resolution's very good, but we don't have access to it anymore. So for me, one of the fundamental and key areas help me sleep better at night is if we actually had a proven, funded, secure, sovereign PNT capability for the UK. So I think you mentioned earlier, where would I, what are the key factors for defence? PNT is definitely right up there for me.
Yeah, it doesn't sound that sexy, does it? But so I guess my final question, because we're going to have to talk about this again at some stage. There's so much we haven't covered. So if you were God for the day, where do you think in the next 10 years the most exciting capability, where's the most exciting potential in space, either for defence or commercially?
Without doubt, the most exciting and the most potential on both factors for me is in-orbit service assembly manufacturing. There's so much that can be done there, and it's so, from producing new materials to new drug delivery, you can producing very high quality semiconductors in space, refueling in space, which will extend our capabilities to actually manufacturing and extending the lifetime of some of our satellites. It has so many possibilities. So for me, that is really, really exciting. Yeah.
That sounds like Star Wars, doesn't it?
It's interesting sometimes, you see these sort of sci-fi movies and whatever, and actually so much of it, you think, oh, okay, yeah, that's coming true, that's coming true, that's coming true. We all have a bit of a giggle when we see, the James Bond, what was it? It was Skyraker or whatever. Moonraker, and they're all jumping around in their little suits and whatever. But,
I'm just a bit unsure about the transporter system. I'm not sure I'm quite ready.
They're very, very large Pinterest.
Yeah, very large. Julie, it's been a massive pleasure. Thank you so much for coming in. I've got a feeling this is going to be a sort of more regular drumbeat, because so much is happening in this space. But for now, thank you so much for your time.
Thank you. It's been great. Thank you.